Hi everyone, in this video we're going to learn a shortcut method for dividing polynomials. However, it's called synthetic division. It is a shortcut, but it only works for certain specific cases. So let's look at what those cases are and how it works. So firstly, let's make an observation. Recall that if I have a division of this form, I compare the first term, I get an x squared. I multiply x squared with both of these, and I get that expression. Then I subtract, and I get 7x squared. I bring down the next term. Again, I compare x with the first term, and I need a 7x. I get a 7x squared minus 21x, which I subtract, but negative 5 plus 21 gives me a 16x. And then I bring down the last term, and the final comparison, this becomes 16x minus 48, which when we subtract is going to be 53, which is the remainder. Now, an observation that I want you to make here is that at each step, what is really important are these numbers, right? Because once we write it down in decreasing powers of x, namely x cubed, x squared, x, and then constant, what determines the entire process are actually just these numbers. These numbers, it's not determined by powers of x because we know that it's going to be x squared here first, followed by x, followed by constant. We made sure of that by following the rule of writing everything in decreasing powers of x. So what's important is that it's just the coefficients that determine the result. And that is exactly what leads to the process of synthetic division. So in the synthetic division case, we are only going to look at coefficient. Okay. But the catch is that it only works for division by polynomial of the form x minus c. So you cannot use it if you are dividing by a degree 2 polynomial, like an x squared plus 3 or something like that. And if you are dividing by, say, 2x minus 1, even then it's not directly applicable. You have to work around and do something about it. But in case you're dividing by x minus c, it is straightforward. So let's look at the above example and then do this using the process of synthetic division. So in this case, we just write down the coefficients of all the terms here. Okay, so the coefficients of these terms are 1, 4, negative 5, and 5. Next, I write down the number that is c, right? So 3. Then I draw a line, and now this is how the process goes. I copy this number down as it is. Then I multiply these, and the result goes here. So that is 3. And then I add them up. That's 7. Then I do the same, and I copy this here. 3 times 7 is 21. And I add these up. That is 16. And then 3 times 16 is 48. And I add them up, and that is 53. And I box that out. Now if you compare these two results, you see the 53 matches up with the last number, and the 1716 matches with the coefficient. So once you have these numbers, what you do is 1 is going to be coefficient of x squared, 7 is going to be coefficient of x, and 16 is going to be the constant. So that will give you the quotient, whereas the last number here is going to give you the remainder. Now, how do we determine what this power of x should be? This first one is always 1 less than the highest power here. Okay. One way to think about why that makes sense is because it's an x cubed and you're dividing by x. So what you expect in the end is an x square type of term. Let's look at a second example. Now in this case, what you have to be a little careful about is this is not in x minus c, right? It's x plus c. So we just do a small step and we rewrite this as x minus negative 2, right? Because an addition can be written as product of two subtraction. And the second thing we need to do is make sure that you rewrite in a way that you include all the coefficients. So this is 0x squared plus 6x plus 8, which means now you're all set up. So the coefficients are 5, 0, 6, 8, and c is negative 2. The first one is copied as it is. Negative 2 times 5 is negative 10. You add is negative 10. Negative 2 times negative 10 is 20. Add 26. Negative 2 times 26, negative 52. Add them up, negative 44. So the remainder in this division is negative 44, and the quotient, the highest power here is x cubed, so it must be 1 lower. So it's 5x squared minus 10x plus 26. So that's an example of how this can be used quite simply to find results of divisions which are made with linear coefficients, or polynomials which are linear, right? Okay, now a consequence of this method is that remember how we can express a function as a division as, so for example, if I divide a by b, right, and in this division I get my quotient to be q and my remainder to be r, this means that I can write a as b times q plus r. Right, for example, 7 over 2, the quotient is 3 and the remainder is 1, which means I can write 7 as 2 times 3 plus 1. And we can do the same thing with remainders, right? So if f of x is being divided by, it's been divided by x minus c, and the quotient is qx and the remainder is r, then we can say that this is true. Right? But what happens? Let's see what happens if x equals c, which means f of c becomes c minus c q of c plus r, but c minus c is 0, so this is just r. This means that when you use synthetic division, the remainder that you get is also the value of the numerator at the point c. And this result is called the remainder theorem. So for example, if you are given this function and you are asked find f of 2, one way that you know is that you plug it in. You go 2 cubed minus 4 2 squared plus 5 times 2 plus 3 and so on. But now we are learning this new method, which is use synthetic division and find the remainder, which is a much faster approach, because that means you put a 2 here and you go 1, negative 4, 5, 3, 1, 1 times 2, 2, gives you negative 2, 2 times negative 2, negative 4, gives you 1, 2 times 1 gives you 2, which is 5. So this remainder, this is simply f of 2. So, which means, for example, in particular, if you have a larger number like f of 10 that you're trying to find, instead of doing a very complicated calculation here, you can do a much simpler synthetic division just to find a remainder, and whatever the value of the remainder is actually the value of the function at that point. Okay, so this is called the remainder theorem, and this can be used for finding values of function at a particular point. So that's it about synthetic division, and also that's it for this video. The last thing left to be done, which will be in the next videos, is going to be again, we're working with rational expressions, but now we will go one step further and talk about rational equations. So what if these expressions have to equal a certain value, and how do we solve those kind of equations? Okay, thank you.